So our next question here is about integration again, and it says that the area bounded by the curves x square plus y square is equal to 2x and x square plus y square is equal to 4x, and the straight lines y is equal to x and y is equal to 0 is given by which among these four. So here this is a multiple choice question, right? So that means one answer here would be correct. So let us have a look at its solution. So for the solution, and in order to calculate the area bounded by the curves, we are to see what is the region bounded by these four curves, these two circles and these two straight lines. So let us first visualize this thing. So let me draw the coordinate axis. This is your x-axis, this is y-axis. So accordingly, you have here this circle x square plus y square is equal to 2x, right? Okay, so we have this circle here having equation x square plus y square is equal to 2x. So in order to see where does this circle lie, so what you can do, you can complete the square of x here, so that it would become x square minus 2x. Now how do you complete the square? You divide this mixed term with 2, that would be minus 1, take its square, that would be plus 1, so you add plus 1 and moreover you subtract plus 1, so you have plus y square and minus 1 is equal to 0. So this term now becomes x minus 1 whole square. We have plus y square and you can shift this minus 1 to the right hand side, so you have this equation. Now this is the equation of the circle where the center is obtained as the point 1, 0, because the general equation of circle is x minus a whole square plus y minus b whole square is equal to r square. So basically it has center as the point a, b and radius as r, right? So in this case we have center as a point 1, 0 and radius equal to plus 1, right? So our circle would be centered on this y-axis. This point is 1, so this is our 1, 0, right? And having radius as 1, so this would be the point 2. So suppose this is 1, so your circle will pass through these points here. Suppose this is minus 1, so this would be our circle, right? Now for the second curve, we have x square plus y square is equal to 4x. So again we can complete the square in the same manner. So we would have x square minus 4x plus 4 plus y square minus 4 is equal to 0, or you can write here x minus 2 whole square plus y square is equal to 2 square. So here this equation of circle has center equal to 2, 0 and the radius here is equal to 2. So accordingly when you draw this, so here the center is at this particular point and the radius here is, suppose this is 3 and this is 4 and the radius here is 2. So that means your circle would go from here to here. This point is minus 2, right? Here to here and from here to here. So our circle would go somewhere like this, right? So this is our circle. So this circle has equation x square plus y square is equal to 4x and this circle has equation x square plus y square is equal to 2x. And moreover we are given two more curves. One is the straight line y is equal to x and another is y is equal to 0. Y is equal to 0 means we are talking about this x-axis only. So this is our line y is equal to 0 and the line y is equal to x will go at an angle of 45 degree from here, because it will pass through the point 0, 0, and let's see where this y is equal to x line cut this square as well as this square, right? So we'll calculate the point of intersection of the line y is equal to x. So point of intersection of the line y is equal to x and circles these both, x square plus y square is equal to 2x and x square plus y square is equal to 4x. So when you will write y is equal to x, so you will have 2x square is equal to 2x, or you obtain the value of x as equal to 0, 1. So here you have the value of x as equal to 0 or it is equal to 1. So that means the point here is either 0, 0 or the point 1, 1. So here the circle meets this line at this point, either 0, 0 or here at this point 1, 1. And let's see what about the other circle. So when you substitute x is equal to y here, so you obtain 2x square is equal to 4x, or you obtain x square is equal to 2x, or you can write x into x minus 2 is equal to 0. So you have x is equal to 0 or x is equal to 2 as the 2 points. So you have the first point as 0, 0 and the other point as 2, 2 because y is equal to x here. So your other point here is equal to this point. So that means your line will make an angle 45 degree and passes through these points. Right, so this obviously this is a straight line. So you have y is equal to x as this line. So now what is the region that you are interested to calculate the area? So the region of interest is that bounded by this circle. Right, let me mark this this circle, right, and this line, this y is equal to 0 and the line y is equal to x. So this is our area of interest here. So in this case we are to calculate the area of this particular portion. So what is the formula to calculate area? To calculate area we are to take we can do that in either the Cartesian coordinates or in the polar coordinates. So here we will use the polar coordinates because it would be more easy, because if you see this is a sector like area. So we have a sector like area, right? So here the limits of r and theta are very easily defined. So here you are to determine for the area what you will do. You will draw a ray starting from origin passing through like this. So you will calculate what is the value of r here and what is the value of r here, and moreover you will see in order to cover this whole area you are to move from this point to this point. So here you will see what is your angle theta, and moreover you see here what is your angle theta. So obviously here the angle theta is equal to 0 because this is your initial line, and this line y is equal to x. If you remember, for this line theta is always equal to pi by 4, because what is theta? Theta is tan inverse of y by x, and here y and x they are equal, so you have tan inverse of y by y. So that means tan inverse of 1. Tan inverse of 1 is pi by 4. So here this makes an angle pi by 4 with this line. So obviously the limits for theta they vary from 0 to pi by 4. So this is done. Now coming back to the portion of r. So in order to determine the limits for r, so let's see how can we obtain that. So for this particular circle we are to see what is the value of r here. Now this is the equation of first circle, this is the equation of second circle. So let me do the calculation here. So it would be x square plus y square is equal to 2x. Now you know the relationship between the polar and the Cartesian coordinates. So you have x is equal to r cos theta and y is equal to r sin theta. So you can substitute all these values in the given equation of circle, so that it becomes r square cos square theta plus r square sin square theta, that is equal to 2r cos theta. So now you can simplify this. So this becomes equal to r square, that is equal to 2r cos of theta. So from here you can obtain the value of r as 2 cos theta. So this is the value of r which is obtained for this circle. So that means when this arc reach at this point on this first circle, so the value of r is equal to 2 cos theta. So your lower limit here is 2 cos theta. Now coming back to the upper limit, in upper limit you have to see this arc reaches this second circle. So for the second circle we have this equation. So we can also convert this equation into the corresponding polar equation. So we have this as your polar equation, right? I can write again the value of x as equal to r cos theta and y as equal to r sine theta. So this becomes equal to r square cos square theta plus r square sine square theta. This is equal to 4r cos theta. So again you can simplify this. So when you simplify, you obtain r square is equal to 4r cos theta, so that you obtain r is equal to 4 cos theta. So this is your upper limit that you obtain from here. So we have 4 cos theta here. And moreover, if you remember, area in polar, that is obtained by writing the values of r and theta. And here we have Jacobian dr d theta, and the value of function here as 1. Now the Jacobian in this case, when you shift from the coordinates xy to the coordinates r and theta, that is simply equal to r. If you do not remember, just go and look back at your class notes for this topic on multiple integrals. So this value is r, and the function's value we take that to be equal to 1, right? So this is the formula. Now we just have to solve this integration. So for solving this integration, we would require to first take the integral with respect to r, keeping theta constant. Now there is no theta, we only have r. So the integration of r with respect to r, that would be r square by 2. And the limits of r, they vary from 2 cos theta to 4 cos theta and d theta as such. So we can substitute the limits here. So it would be 4 cos theta square minus 2 cos theta square divided by 2, and the integration is with respect to theta as such. Okay, so what is this integration? How can we solve this? So here we can simplify this term. So it would be 16 cos square theta minus 4 cos square theta divided by 2 d theta. So this is equal to, you have 16 minus 4, that is 12, and 12 divided by 2, that is 6 cos square theta d theta, and the integration varies from 0 to pi by 4. So 6 could be taken out. So this integration is simply that of cos square theta, and you can write cos theta as 1 plus cos 2 theta by 2 d theta. So when you perform this integration, it would be theta by 2, and here you have sine 2 theta by 4, and the limits of theta varies from 0 to pi by 4. So finally it would be equal to 6 as such. When you substitute the upper limit, it would be pi by 8, and when you substitute the upper limit here in this term, sine 2 into pi by 4, that means pi by 2 divided by 4. This is the upper limit, and you substitute the lower limit, it would be 0 plus sine of 0, 2 into 0, that would be sine 0. So this term would be 0. So we have 6 into pi by 8. Now sine pi by 2 is 1, so we have 1 by 4. So this term becomes equal to 3 pi by 4 plus 1 by 2. So this is the value of the area of the given region that was required in the question. So let's have a look at our options. So from here, from the given options, we have either this option true or this option true. So let's have a look at a solution. Here we have 3 pi by 4 plus 1 by 2. So accordingly, 3 pi by 4 plus 1 by 2, our option B here is the correct option. So I hope you understood this question.